A very good afternoon to all of the subscribers of the Global Energy Association. We're continuing today our series of chats with the people who've been shortlisted for this year's prize. And today we're talking to Dr. Richard Goldstein from the United States. Hello, Dr. Goldstein.
Hello, pleased to be here.
Let me try to introduce you in simple terms. You are considered a pioneer in velocity and other optical measurements. Dr. Goldstein was nominated for development of cooling designs widely used in high-performance gas turbines, novel and important measurements in thermal convection, and major leadership roles in the engineering community. Then, Dr. Goldstein, when I was reading your profile, I came across a word which is familiar to most people who've been to a secondary school, but which, given the circumstances of our chat, is rather surprising. Doppler, the Doppler method. What does the Doppler method got to do with your research?
Well, the Doppler method is an optical technique that I was one of the early pioneers on a number of years ago. It measures the Doppler shift of light radiation, actually laser radiation, from a moving particle. So you can measure flow velocity optically. So
hold on a sec, but usually this word is referred to astronomy, and we're talking about energy here.
Well, this is not directly energy. It's measuring velocity, which you have to know in terms of your energy transport. So
tell me more about it.
Well, basically, a Doppler shift is a change in the frequency of light due to motion of the transmitter, or in this case, the reflector. You scatter light off of particles, and you measure the change in the frequency of that light, and that's a measure of the velocity of the particles. So the particles are small particles that you add to a flow, so you can follow the flow. It's a widely used technique now. We worked on a few others and I worked on the development 40 years ago.
I've been asking wider questions. Yeah, I've been asking wider questions to all the people who've been shortlisted, because it's up for the technical experts to decide the fate of you, and of course our international committee. But we are in a turbulent world, and in a world where the energy environment is changing. So let me ask you this. In Russia, more than half of electricity is generated by thermal power plants. And the situation is indeed similar in other European countries and in the United States. What is surprising is that for some reason, we hear a lot about renewable energy. It's not for some reason, it's quite explicable actually, and hydrogen, etc., but almost nothing about the heat power. Why? Well,
in the US, we're not as good as many countries in Europe are on renewable energy. But one of the reasons is, as in Russia, we have a lot of gas. I was just talking to someone the other day who's an expert on this, and he said, you'll never find a coal-powered plant being built today in the US. There are all these these combined cycle plants, which have amazingly high efficiencies of the order of 65%. When I was a student some years ago, if you had a power plant that had 35% thermal efficiency, you were happy. Now these go to 65%. It's just amazing. But it's mostly gas. Now we have some nuclear, but we're not building any more nuclear. But the main thing that we're building today are these combined cycle gas turbine, steam turbine power plants. Using gas as a fuel, natural gas.
Are the renewables going to replace the traditional energy?
Pardon? Are they replacing the traditional energy?
Yeah.
Well, they're replacing coal. Coal had been, 44% of our power used to come from coal, electric power. Now it's going towards zero.
What do you say to the coal miners?
That's a problem. Get a different job. I mean, that's a political problem. So.
Well, it is, but is there maybe something on the horizon for the coal industry to maybe start coal-based chemistry industry, that sort of things?
I don't think so. I mean, it's very hard. I mean, they talk about clean coal here, but there's no such thing really as clean coal. I mean, you burn coal, you get a lot of carbon dioxide, or you combust it in any way, you get a lot of carbon dioxide. I think coal is on the way out. It is a political question because there are in a number of states very strong coal mining industry, and it's a tragedy for people that have worked in that industry for a lifetime, and then suddenly the industry goes away. So it is a tragedy.
Last week, I heard a piece of news about even oil and gas companies stopping exploring new oil and gas fields because they think that renewables are going to replace just everything in energy. Do you believe in that?
Well, it would be nice. I'm a big fan of renewables, but I'm a big fan of some things that aren't always so popular. The problem is renewables are very hard to get started and tend to be very capital intensive. Now, you know, it also tend to be not quite as reliable or regular. I mean, the renewables, other than maybe hydropower and some wind power, tend to be transient. You know, the sun doesn't always shine, so you don't get solar power in the evening. Even water power isn't dependable. While if you had a gas plant or even a coal plant or a nuclear plant, you can run those 24 hours a day.
Another transformational example that has led to huge energy savings and in turn monetary savings is your path-breaking engineering of film cooling of advanced gas turbines. Does this increase the lifespan of the turbine blade?
Yes, you know, I heard a talk. I was at a meeting sometime, and one of the co-inventors of the gas turbines, Sir Frank Whittle, was there, and he said what amazed him about modern gas turbines, this was some years ago, was not that they're so big or they can drive such powerful things as a huge commercial airliner, but that they can run for thousands of hours without major maintenance. He said when he ran his gas turbines, they ran for 5 minutes, they were happy because they burned out. And what film cooling is a means of protecting the turbine blades. You have to realize when you get on an airplane that the gas coming into the hot section of the first stage is above the melting point of the blades, not only the failure point, the melting point. So somehow you have to keep those blades from getting to that temperature. And film cooling is just a technique that we developed some years ago that's used in almost every commercial or military engine.
On the 8th of September, we will announce the final results. The decision by the International Award Committee, who will in turn gather on the 7th to decide whom to choose out of 15 persons, people who are there. If you were present at the International Awards Committee meeting, how would you recommend yourself?
Well, I'd recommend myself highly, probably, but well, let's see how things go. I don't want to brag or anything.
But in simple terms, because we are being listened to now, this is being recorded, we're going to be putting it out.
I do a number of things related to energy. Film cooling and gas turbines is one major one, but I do other things. I worked on things related to solar energy, related to nuclear power. I've done a lot of things on energy. I've run a lot of meetings specifically on energy, and both all over, and also with some people from Russia. And energy has been a key parameter in most of my work. Some of it is very basic, so you don't always see the energy point. Some things like film cooling, it's pretty obvious how it's related to energy.
Now that you've mentioned the solar energy, here's a tricky one. All of us admire the technology. It's so nice. You've got the sun there up in the sky. You just put a battery and you go forward and forward. But the problem is, of course, with the panels themselves, because when you produce them, firstly you use some energy, but that's okay, let's put it out of the brackets. But also the materials used in a lot of non-conventional energy are not so innocent. So you save the planet from the kind of the pollution that you have now, but you provoke new pollution. What do you do about this?
Well, that's a problem you have to work on. You know, nothing is free. So every solution has its problems to it, including solar energy. I'm not sure that there's anything particularly negative in the materials that are used in solar energy systems, certainly in the flat plate collectors that you seem to be talking about. I think that the materials are pretty standard and not particularly deleterious to the environment, but there's still a lot of material, you know, a lot more material than in a more concentrated energy system.
very lastly, I try to make this conversation shorter so that people know more about our laureates, but don't, you know, fall in love just with one of you. Very lastly, a lot of recipes which come from our distinguished candidates are breathtaking, and they're through 21st, if not 22nd century. Yet, what preoccupies me always is that a lot of these inventions and a lot of these ideas are very good for the first world, for the rich world. Are they applicable in the developing world? Aren't we, you know, making the gap even wider when we launch all those new technologies in the north, so to say, and we don't think really if it can be massively used in places like Latin America, Africa, and developing Asia?
Well, certain things. I recall being somewhere in Africa, and we went to this village, and all of a sudden I heard some radio playing, and what they had was a little solar energy panel connected to a radio, and they had this. All it was doing was driving the radio, but they loved it. And the point is, in developing countries, it's hard because most energy systems are expensive, and you have to have the money to do it, but you can't get away from it. You know, there's no way to get free energy. I mean, true solar energy, you can do things pretty neatly. You can get hot water fairly simply. It's still not directly done. You have to still have a collector and a storage system and everything, but certain things are good. But to get power, electric power, which is the thing that seems to be required to get our modern civilization going, then you have to have some conversion system, and the conversion system tends to be expensive to convert it to electricity.
As Goldstein, it's typically said that the difference between an optimist and a pessimist is that the pessimist is the same optimist but better informed. But in your case, I can see an optimist which is well informed and who is still an optimist. Congratulations.
Thank you. Well, I am optimistic about the future in the world, including what we call sometimes the third world. But I think the third world requires investment from the first world. You know, they can't do it by themselves. It's too far behind. They have to get more help.
Absolutely, sir. Well, we're entering the political conversation here, which I don't want to pursue. So thank you so much, and best of luck as far as the International Award Committee's decision is concerned.
Thank you very much. Appreciate the conversation. Stay well.
Thank you, sir. Goodbye.